Hello, children. Today we will start our next exercise, that is exercise 7.6. Okay, so in this exercise, we will use one more method that is known as integration by parts. So, what is it? What is integration by parts, and how can we solve the question related to that concept? Got it? So first of all, you should learn this formula. Suppose there are two functions. Okay, there is fx and gx. These are two different functions. So if you have to find out the integration of these two different functions, okay, so how will you find out the integration? So you will use integration by parts. Fine. So suppose fx is your first function, gx is your second function. I will tell you how can you make this first function second function. Okay, when we will do some questions related to that formula, then you will understand. Okay, and I will give you the formula for this. How can you choose the first or second function? So just remember now, just assume that this is your first function, this is your second function. So your formula is your first function, that is fx, will remain the same into integration of your second function. Your second function is gx. So integration of this minus now derivative of first function. This is the derivative of first function into integration of second function, and this whole integration. Okay. So this is your formula which you will use. Okay, now one more formula you have to learn, that is known as eyelet. This I stands for inverse trigonometric function. This L stands for logarithmic function. This A stands for algebraic function. This T stands for trigonometric function. Okay, so this I stands for inverse trigonometric function, and this T stands for trigonometric function, and this is your exponential. Exponential function. Got it? So this is the order of the function which you will take. For example, if we have to find out the integration of x, cos x into dx. So this x is your algebraic functions and this is your trigonometric function. Now in this formula you have to check which function is coming first. So this x is algebraic, here it is algebraic, and this cos x is trigonometric. So after that, so this is it, this x is algebraic function is coming first and then trigonometric. So this is your first function and this is your second function. Are you getting my points? Is it clear, children? Okay, so this is the order which you will select. And now for this is your first function, this is your second function, and the same formula you have to apply. See, how will you solve this? Your first function, according to this formula, your first function will remain the same, and you have to find out the integration of this. So integration of cos x will be, I'm just going to find out the value directly. So the integration of this, that is minus sine x. Okay, then minus sine, this minus sign you have to write, and this integration, this bracket. Okay, this integration, this bracket, and derivative first function, derivative of x will be 1. So I'm not writing into your integration of second function. Integration of this would be minus sine x, then dx. Got it? So this would be minus x sine x. This would be plus. So the integration of sine x would be minus cos x plus c. Got it? So this is your sine x minus cos x plus c. So this is the required answer. Okay. Okay. See, the integration of this cos x would be plus sine x plus sine x. You have to write plus sine x. Okay. Because the integration of cos x would be plus sine x. So you have to write, and integration of this sine x would be minus cos x. Fine. So this will remain negative. Fine. This negative will come, this will make positive. Fine. And similarly this will be positive. Okay. So this is your final answer of this question. Got it, children? So this is how you can apply this concept. Got it? Now see, children, we are starting this exercise 7.6. Okay, the first question is very simple. You can solve. Question number 2 is also very simple. So here I'm going to solve question number 3. So this is your I is equals to, let I is equals to integration of x square into ex into dx. Okay. So first of all, you will use eyelet. So here exponential function and algebraic function is coming. So exponential function is this and algebraic is this. So algebraic function will be the first function and this will be the second function. Got it? So according to the formula, your first function will remain the same into integration of this function, integration of second function minus derivative of first function. So your first function is x square into integration of your second function, and the answer which will come, the whole integration of this. Okay, so here I'm writing dx. Got it? Now this x square will remain x square, integration of ex will remain ex, minus derivative of x square would be 2x into integration of this ex will remain ex, and this whole integration. Got it, children? Now x square ex minus 2 will come outside, it would be x ex into dx. Fine. Now as you can see here in this step, again you have to use the same technique. This is your first function, this is algebraic and this is exponential. So this is the first function, this is your second function. So in this question, in this part, again you have to apply the eyelet. So this will remain same, x square ex minus 2. So here I'm writing this big bracket. So your first function will remain same, the integration of this. So integration of this would be, it will remain ex. Directly I'm showing the integration. Minus the derivative of this x, it would be 1. So I'm not writing because derivative of x would be 1. And integration of this ex will remain ex, and integration of this ex also. Got it? So plus c, this is will remain x square ex minus 2 x, ex minus integration of this would also ex plus c. Okay, just insert this 2 inside it. Fine, and that would be the final answer. So your answer is x square ex minus 2x ex plus 2ex plus c. So this is your final answer of your question number 3. Got it, children? So practice this question. After question number 3, question number 4 is very easy. You can solve. Question number 5 is also easy. Question number 6 you can try. Fine. And question number 7 I'm solving. Okay. So your question number 7, that is I is equals to integration of x sine inverse x. Okay. So according to Eilert, this inverse, this is your first function. Okay, and this is your algebraic, this is your second function. So again apply direct formula. Your first function will remain the same. Here I am showing each step. Okay, your first function will remain the same, this one, into integration of your second function, that would be x square upon 2 minus or derivative of your first function. This is your first function, or derivative of sine inverse x would be 1 over under root 1 minus x square into integration of your second function, that is x square upon 2, because the integration of x would be x square upon 2, and integration of the whole result. Okay, plus c you can write. Are you getting, children? Now this is your x square upon 2. It will remain sine inverse x minus 1 by 2 integration of x square over under root 1 minus x square plus c. Okay, just you have to calculate the integration of this part. Fine. So your I is equals to x square upon 2 sine inverse x minus half. You can assume that that is your I1 plus c. So I'm assuming that this is your I1. So this is your equation number 1. So your I1 is integration x square over 1 minus x square. So here you can subtract 1 or you can add 1. Fine. So x square minus 1 over under root 1 minus x square integration of this into dx. So I am separating these two, x square minus 1 over this and plus 1 over this. Got it, children? So in this, if you will take minus as common, so you'll get 1 minus x square, and here 1 minus x square is already coming, but it is in under root, plus, and this is your sine inverse x by a. So that formula you will apply here. The formula is sine inverse x by a. Your a is 1, so no need to write 1. So I'm showing it just plus c. Okay, so when you will cancel these two, you can cancel, you will get under root 1 minus x square into dx. Actually we have to show the integration also with this, plus sine inverse x plus c. Now children, there is a formula of this. Okay, so you can take the formula of a square. This is your 1, So you can write 1 square. Okay, so this is your a square minus x square. So there is a direct formula for this which you will study in your next exercise after this exercise. Okay, so then I will tell you how which formula you will apply, or now you can directly see in your NCERT and you have to apply the formula. After that you will get this value. So this is your I1. Fine. So put this value of I1 in this equation at the place of this I1 and you will get the final integration of question number 7. Got it? Or if you want to solve this I1, okay, so I will give you the another method for this. Just wait. So this I1 you can also solve. So this is your I1. Okay, so at a place of this x I am putting sine theta. Okay, so derivative of this would be dx upon d theta, that is equals to cos theta. Okay, so this will give you dx is equals to cos theta into d theta. Fine. So integration at a place of x, here you have to write sine square theta over, and in denominator you will get 1 minus sine square theta. So that is your cos square theta under root. Okay, at a place of x I am putting sine square theta. So 1 minus sine square theta is cos square theta, and at a place of this dx I am writing cos theta and d theta. Fine. So integration sine square theta, this is your cos theta into d theta over cos theta, because this is in under root. So this cos theta and cos theta you can cancel. Got it, children? So you will get sine square theta and d theta. Fine. So formula of sine square theta is cos 2 theta. Just wait. So here I am showing it, the formula. Okay, so your cos 2 theta, that is equals to 1 minus 2 sine square theta. Fine. So if you have to find out the value of sine square theta, 2 sine square theta, that is equals to 1 minus cos 2 theta. So your sine square theta would be 1 minus cos 2 theta over 2. So at the place of this cos sine square theta, you have to put this value 1 minus cos 2 theta whole upon 2 into d theta. Got it, children? So you can find out the integration of this. Okay, so 1 by 2 you have to separate. This would be wait, I'm solving it on the next page. Just wait. Uh, 1 by 2 d theta, this is your first part, minus 1 by 2 integration of cos 2 theta d theta. So this will be 1 by 2 theta minus 1 by 2 cos 2 theta, integration of cos 2 theta is sine 2 theta over 2 plus c. So just replace this theta. This theta would be, your x is sine theta. Your x was sine theta. So the theta would be sine inverse x. Sine inverse x minus half sine 2, and your theta is sine inverse x plus c. Okay, so put this value of I1 in equation number 1, which is this, in this equation. you have to put this value of I. Okay, so any one of the method you can use. Fine. So note it down, children. After that, children, in question number 7 we have done. Question number 8, it is again same, x tan inverse x, it is same. Question number 9 is also same, you can solve. In question number 10, in question number 10 in question number 10 uh, your I is equals to sine inverse x and whole raised to the power 2. Okay, this is given to us. So in this question, what you have to do, I am assuming that your sine inverse x is equal to theta. So your x would be sine theta. Got it? So if you'll differentiate it, you will get dx is equals to cos theta and d theta. So now integration, this is your sine inverse, at a place of x I am putting sine theta, and this whole square, and at a place of this dx I am writing cos theta d theta. This sine inverse x and sine will cancel out and you will get theta square cos theta and d theta, integration of this. So again apply eyelet. This is your algebraic function, this is your trigonometric function. So this is your first function, this is your second function, and after that you can easily simplify this question. Okay, but at last when you will get the answer, so you have to replace theta, you have to write the answer in form of x. So replace theta with sine inverse x in the last step. Okay, so this is how you can solve question number 10. And now question number 11 I'm solving. Okay, question number 11 I'm going to solve. I is equals to integration x cos inverse x over 1 minus x square is given to you. Okay, children. Now here I am assuming that cos inverse x, that is equal to t. Okay, or you can say theta, you can assume that is equal to theta. So your x would be cos theta. Fine, and if you'll do the derivative of this here, so you'll get dx, that is equals to minus sine theta into d theta. So here I am putting this value. So your x is cos theta cos inverse x. So when you will put this value of x here, your cos inverse and cos theta, this and this will cancel out, over under root 1 minus your x is cos theta, so 1 minus cos square theta, and at a place of this dx you have to write minus sine theta and d theta, like this. Got it? So this minus sign you have to write outside, and in numerator part you will get cos theta sine theta and d theta over, and this would be 1 minus cos square will be sine square, so under root is there, so this will be sine theta only. So this sine theta and sine theta will cancel out, and integration of cos theta into d theta. So integration of cos theta would be sine theta plus c minus sine, at a place of theta I have to write cos inverse x plus c. So this is your required final answer. Just wait, children. I think there is some problem in this question. Yes, here it is. Here there is a one theta also, so which we have not written. So theta will come. Okay, theta will come because this step will not you will use. Okay, so here theta, cos theta, and d theta will come. Fine. So here again you have to apply eyelet. So this is your algebraic function, this is your trigonometric function. So this is your first function, this is your second function. So just you have to simplify it. Minus sign will remain outside. Okay. So here I'm writing the first function will remain the same, and integration of this cos x. So integration cos x will be cos theta will be sine theta minus, and derivative of this theta would be 1. So I'm not showing here, and the integration of this would be sine theta, and this whole integration also. Fine. So this minus theta sine theta, and this minus and minus will be positive. Fine, I'm inserting this negative here, and integration of sine theta is minus cos theta, okay, plus c. So replace the theta. This is your cos inverse x sine, and at a place of theta I'm writing cos inverse x plus minus. So write minus, this is cos, and cos inverse x, this cos and cos will cancel out, this x will come, plus c. So this is your required final answer. Okay children, so this is how you can solve this question. So note it down. Now children, there is a one more formula. See, if there is a ex outside, okay, and integration sign is there, if there is a fx plus f dash x, suppose if you have to find out the integration of this kind of function, ex will be in outside, and there is a function fx plus there is a f dash x. So your final integration will be ex and fx plus c. So this would be the final answer of this kind of integration. Okay, so here I'm solving a question. Just wait. See, question number 16. So here I is given to us, integration e raised to power x sine x plus cos x. This is given to us. Okay, so this is your fx. If you compare, ex is coming outside, and this is your fx, and the derivative of sine x is cos x, and this is also given to us. Okay, so your final answer of this question would be ex and your fx was sine x. So this will come. If it is coming in 1 mark, so directly you can apply this formula. If it is coming more than that, okay, if it is coming, suppose it is coming for 4 marks, okay, or for 2 marks, so you will not get any question of 2 marks in your board exam. Fine. So this year I'm not sure about it, but from last years there's a question of 1 mark, 4 marks, and 6 marks. So there was no any question of 2 marks. Fine. So if you're getting this kind of question more than 1 mark, so how will you solve it? Just please concentrate here. So in this question, what you have to do, second method here I'm showing. So you have to insert ex. Integration dx and dx. Your fx, this part, fx and ex, you have to solve, and this part, the second part, you have to leave it as it is. Okay, so here I'm applying eyelet. So this is exponential function, and this is your trigonometric function. So this is your first function and this is your second function. Fine, because exponential function is coming at in last. So when you will apply eyelet. So according to the formula, your first function will remain the same. Integration of this function, that would be ex, it will remain ex, minus derivative of this function, it would be cos x, and integration of this function, it will remain ex, and integration of this also, the integration of both, plus integration ex cos x and dx, and this will cancel out. Okay, plus ex sin x plus c, this will come. So this both answers are coming same. Okay, so this is how you can solve this question. Okay, children, so practice this. Now, student, we are going to solve question number 17 of this exercise. Okay, and this is your question. So, how can you solve this question? So here I'm going to telling you how will you solve this question. So in this question, what you have to do, you have to keep ex outside this, and this is your x. So add 1 and subtract 1 also, over 1 plus x whole square into dx. Okay, so ex, and this is your x plus 1 over 1 plus x whole square minus 1 upon 1 plus x whole square into dx. Okay, what we have done, this x plus 1 over, I'm writing this one, minus 1 over this one. Fine, so this and this will cancel out, and you will get integration ex 1 over 1 plus x minus 1 upon 1 plus x whole square. Okay, so here this is your fx and this is a derivative of this. Fine, so directly if you want to write the direct answer, so this would be the answer, or if you want to solve it, so insert this ex and solve this part and apply eyelet, and you will get this part also. Fine, and this will cancel out, and finally you will get this answer. So this is a homework and you have to solve. And in the next question, question number 18. So I am solving it, just wait. In question number 18, I is given to us, that is ex 1 plus sin x 1 plus cos x. This is given to us. Okay, so similarly here again you have to simplify this part. It will remain 1 plus, at a place of sin x I'm writing this formula, 2 sine x by 2 cos x by 2 over this 1 plus, and at a place of this cos x I'm writing 2 cos square x by 2 minus 1. So this is a formula. 1 and 1 will cancel out, and you will get ex bracket open 1 over 2 cos square x by 2 plus 2 sin x by 2 cos x by 2 over 2 cos square x by 2. This is square. This cos x by 2 and this will cancel out. 2 and 2 will cancel out, and here you will get tan x by 2. Fine. So I am writing this first. This ex integration sign, and this tan x I am writing first. Tan x by 2 plus 1 by 2, and this is your sec square x by 2, because 1 by cos square x by 2 is sec square x by 2. So as you can see, this is your fx, and derivative of this is this. Fine. So your answer would be ex tan x by 2 plus c. Again, if you want to insert this ex with this, and you have to simplify it because it is matching with the formula ex fx plus f dash x. Okay, so if you want to solve directly you can solve. If you want to insert this ex with this and with this, and then you will simplify this first part, fine, using eyelet. So you can use that method also. So as you wish. Fine. So in question number 19, so it is directly 1 by x and 1 minus x square. It is fx is given minus f dash x is also given. So directly you can apply the formula. Question number 20. Okay, this question I'm telling you how will you solve this. Okay, after that the rest of the questions you can solve. So now I'm solving question number 20 of your NCRT. So x minus 3 over x minus 1 cube into ex. So this is given to us. Okay. So this ex will remain outside. And this x minus 1 minus 2. So this minus 3 I'm writing like this. This is cube. So ex x minus 1 over x minus 1 cube minus 2 over x minus 1 cube. And dx you have to write outside. So this and this power will cancel out and you will get ex 1 over x minus 1 square minus 2 over x minus 1 cube. So again, this is your fx plus this is your derivative. Okay. So again, you can apply the formula. Directly you can solve, or if you want to insert this, so this is your wish. So this is your final answer. Got it, children? So this is how you can solve all the question of this exercise. So practice each and every question of this exercise. If you're getting any problem in any one of the question, so please ask. Okay, without hesitation you can ask. Okay, bye bye, take care. थोड़ा सा हम सिलेबस फास्ट करेंगे एज कंपेयर टू आवर प्रीवियस क्लासेस, सो दैट द मैक्सिमम सिलेबस वी कैन कंप्लीट. Okay, bye bye children.